Today we're going to work on lesson 5.7, which is on fractions, decimals, and percents. Please make sure you have your notebook and pencil, and you may need a calculator. Pause the video until you have that stuff, and when you're ready, let's move on. So we are going to be working in a couple of our competencies. We're actually working in two of them right now. The first one is our geometry and measurement. And with this one, we have to define scale factor, identify equivalent ratios and rates, identify and set up the components of the percent proportion. All of this stuff, basically, all of the problem solving stuff is what we're going to be doing in this unit. But with this lesson specifically, we'll go to the next page. We're going to our numerical operations and rational numbers. And we are working with the attending to precisions, where you have to be able to accurately convert between fractions, decimals, and percents. And you can see it's in every single one, beginning, approaching, and competent, depending upon how you do it, with support, with prompting, or independently. So let's go ahead and get started. First of all, in class, we're going to talk about what you know about percents. We're going to be going over what you know, how you use them, and what you want to know about percents. So I'm sure there's some things that you already know, because this is not the first time you've been working with percents, but we're going to see how much further we can take it this time. So let's take a look at a couple of pictures. What's wrong with this picture? If you look, if we have a grade, this is grading system. First quarter is 40%, second quarter is 40%, and the final exam is 10%. If you add this up, this is 90%. That's what's wrong. We want 100%, and these do not add up to 100%. How about this picture? What's wrong with this picture? If you look, every single part of the pie, so to speak, is the exact same size, but the percents are not the exact same. They're close, but not quite. Not to mention that if we did this way, they would definitely not add up to 100. It would be way more than 100. How about this picture? Again, if you look at it, this is a 100% discount store. Well, if they take 100% off of everything, they are definitely not going to be making any money. So let's do a review problem, and this is from scale factor. The length of the model train car is 2 inches long. The scale of the model to the actual train car is 1 inch to 20 feet. So we're going to set up our proportion. Our scale is 1 inch to 20 feet. And we know that the model train car is 2 inches long, so that's going to go on top. So I can do it two different ways because they're both easy. 1 times 2 and 20 times 2, that would give me 40 feet. But I could probably do it this way also. I want to go this way, sorry. Go up. 20 divided by 20 gives me 1. Nope, I do want to go down, times 20. Sorry about that. 2 times 20 then gives me 40 feet. Still the same answer. So let's go ahead and start with percents, and we're going to start with the definition. So in your notebooks, please write down the definition of percent. A special type of part-to-whole ratio when comparing any number to 100. And that is the important part. Percent basically means out of 100, and that's the part that we're going to be using the most. Pause the video if you need time to write that, and then we'll continue. So let's look at the first example here. The grid has 100 squares. It's basically a 10 by 10 grid, and they shade in 50 of them. So each row here is 10, so 10, 20, 30, 40, 50. So that means we shaded in 50 out of 100. And again, percent means out of 100. So this is 50%. Second example down here, the ratio would be 30 out of 100 because they only shaded in 30. So 30 out of 100. I want that as a percent and a decimal. So again, if you have it out of 100, it's 30%. Now, say this fraction correctly. This is 31 hundredths. 31 hundredths as a decimal would be this. This is tenths, this is hundredths, 30 hundredths. So you can have 0.30 or 0.3, 30 hundredths or 3 tenths. It's the same thing. So this is what you're going to be doing a lot on your homework. You're going to be writing percents, fractions, and decimals and be able to go through all of them. So let's start with 25%. So 25% as a fraction. Remember, percent means out of 100. So 25% is 25 out of 100. So 25 out of 100. But I want you to simplify it. I want it in lowest terms. I can divide both by 25, which is going to get us 1/4. As a decimal, again, this is out of 100, 25 hundredths. So that would be 0.25 tenths hundredths, 25 hundredths. So let's take a look at the next one. I want equivalent fractions for 1/5. So 1/5, we can multiply it by 2. That would give me 2 tenths. We can multiply it by 3, would give me 5/15. Or I could multiply by 20, which would give me 20 100ths. Whoops, 20 100ths. So that would be 20% or 20 hundredths if we put it into fractions, decimals, and percents. So what about if we don't have it out of 100? So now we've got a grid that is only 50 squares big, and we've shaded in 30 of them. So we've got 30 out of 50. So I want it I want it as a percent. So I'm going to put it equal to something out of 100 because that's the percent. So again, if we figure out an easy way, what do you do with 50 to get 100? You multiply by 2. So 30 times 2 would give me 60. So knowing that, we've got 60%. So we have the fraction, we have the percent. All we need is a decimal. Again, 60 100ths, so 60 hundredths, or if you want to take off the 0, it would be 6 tenths. So I'm not going to worry about equivalent fractions. We've already done the fractions, decimals, and percents. So let's go ahead into these. I want to change these fractions into percentages. So I'm going to put them equal to 100. That's what I want to do. I'm going to put all of these equal to 100, and that's going to give me the percent. Okay, so let's figure out easy ways. 5 times 20 gives me 100. So 2 times 20, this would be 40%. 40 over 100 would be 40%. 25 to 100, this would be multiplied by 4. So 10 times 4 would also be 40. So this one would also be 40%. 20 times 5 gives me 100. So 4 times 5 gives me 20. So this one would be 20% because it's 20 out of 100. Have to do a little bit of math here. 40 times what gives me 100? Well, that would be times 2.5. 100 divided by 40 would give us 2.5. So 40 times 2.5 gives me 100. So 11 times 2.5 gives me 27.5. So that would be 27.5 or 27 5/10%. So we're going to fill in the table. The table below shows the batting averages of Aiden, Bob, and Dan. You're written as a fraction, decimal, or a percent. They've given us 1 in each one. We've got to write in the missing stuff. So let's start with Aiden. I need it as a percent, so I'm going to set it equal to 100, which means I'm going to do 10 times 10. So 30 times 10, or 3 times 10, I'm sorry, gives me 30. So that's 30%. And again, 30 100ths as a decimal would be 0.30. Or again, if you just took off the 0, it would be 3 tenths. Let's go ahead and do Bob. Bob has 25 100ths. Well, we'll go back over here to the fraction, 25 hundredths. So again, we know this is 25% because that's out of 100. There's our fraction, 25 hundredths, but I need it simplified. I'm going to divide both the top and the bottom by 25. I get 1/4. That is the answer that I'm looking for. You need the 25 100ths, but you also need to simplify it. Okay, finally, let's do Dan. 40%. We know that's 40 out of 100. So 40 hundredths, that would be 0.40 or 0.4 if you're going to take off the 0. Let's see, what can we simplify by? Let's simplify by 20. How many 20s are in 40? That would be 2. 20s in 100 would be 5, so our answer would be 2/5. So here's a word problem. We have a circle graph that shows how Mary spends her time every day during doing these activities: sleeping, eating, going to school, completing homework, and hanging out with friends. So if we add them all up, I'm pretty sure we're going to get 24. Yep. So we know that 100% is 24 hours. So let's go to the next page. What fraction of Mary's day is spent sleeping and doing homework? Well, sleeping, it was 8 hours, and doing homework was 4 hours. So I want a fraction. So 8 plus 4 gives me 12 out of the 24. I'm going to simplify that. That equals 1/2. There's the fraction. What fraction of Mary's day is spent not going to school? Well, she went to school 7 hours in a day. So not going to school, we're going to subtract 24 minus 7. That gave us 17. So 17 out of 24 was her days not going to school. And you cannot simplify 17 and 24. So now here's a good one. When added together, which two activities does Mary spend 25% of her total time on? So 25% is 25 out of 100, and I want to know how many hours that is out of the 24. So I'm going to take 100, I'm going to divide it by 4, that gives me the 25. So 24 divided by 4 gives me 6. So I got to figure out two activities when added together equaled 6 hours. Well, if you go back, 4 hours was spent working on homework, 2 hours were spent eating. So those, whoops, don't need the S in there. So there's the two activities that she spent 25% of her day on. So your homework is the last 4 pages in the lesson. It's numbers 7 through 24 and 38. So if you put it into Notability, you can go do it right on your iPad. Otherwise, if you're in class, I did give you a paper copy. If you have questions, feel free to send me a message. Good luck.